My name is Felix. I work at Splunk as a senior product manager. Been there for about a year now. But here to talk to you guys about kind of my path to Splunk as a PM. Um, I put together an agenda just to kind of highlight some of the topics that we'll be covering today, namely, compiling detailed requirements from a UI UX perspective, and then also looking at software architecture and design. We'll segue into project management and balancing that with software development practices. Working with engineering teams. I work with 3 engineering teams for the products that I work with, Seattle, San Francisco, and Santana Row. And then we'll look at a couple of, startups, if you will, that I worked on prior to transitioning to Splunk in terms of building product around those types of startups. So a little bit about me. It's a long list, but as I mentioned, currently at Splunk, I also teach part-time at De Anza in the Computer Information Systems department down there. Currently teaching a Java programming and a cybersecurity ethical hacking course. So happy to answer any questions afterwards related to kind of like my path so far, but let's dive right into it. So I guess before we get started, do we have any PMs or aspiring PMs in the audience? Okay, I assume so since we're here, right? So, but like I mentioned, I guess wearing the product hat, when you're thinking of building something, and this is all from the software perspective, generally you don't have a product at that point, right? You have nothing. So some of the topics that I'll kind of demonstrate going from zero to this beta phase where you're actually introducing your product to a customer will span coming up with the idea, who's your team. Again, this is from the software perspective, so you're technically going to be working with engineering teams. How do you manage that team, experimentation, prototyping, iterating on design, both on the software side and then also on the user experience side. Understanding your customer. At Splunk, our customer is the forefront of every product manager's kind of vision behind the product that they're responsible for. And then eventually delivering your POC, right? So this is just a framework that I've used in the past that's been helpful in going from that 0 point to beta, breaking up into phases. By all means, this is not a framework that is, you can tailor this framework to based on, to the type of product that you're actually building. But for the products that I've built before, generally, you're going to spend time determining what your project is, what are the objectives, building an organization and a rough plan around kind of the division of responsibilities as you start to think about who you're going to bring onto your team. Phase 2 generally is, after phase 1 is done, obviously, you're going to have to start to think about who's your market, who's your customer, doing the research to kind of support the idea behind what you're actually going to be selling. Building the preliminary product, the MVP, or service that you're going to be offering to your customers, and then eventually having that beta release with your customers. So how do we get there? So I added a couple of videos here that kind of entail the requirements that have been used for 2 specific startups. It's scrolling through them right now, so I think the intent here ultimately is to give you kind of an idea of what's coming down the pipeline for today. I'll go into details about what these requirement documents actually mean and how they actually get you from that 0 point to building your product. As PMs, generally, you want to defer, responsibilities to your engineering teams and working with them, right? So this is one pipeline in which you can actually help your engineering teams get clarity around what we're building, what we're actually going to be delivering to our customers, and why. So taking a step back, again, this is from the software perspective. Most folks here are probably working in some form of technology to a degree. I mean, do we have any folks in tech today in the audience? I think we have a few, okay. If not, maybe I'll just give a brief background on kind of where we are today. Splunk is a software company. We build enterprise software for Fortune 500 companies. So we're operating in the cloud space now. We also build and sell software that operates on-prem. So specifically in the cloud, what are some common use cases? You have use cases centered around web and mobile apps, data analytics, stream processing, and then also batch computation. Um, I bring these topics up because at Splunk, we're a software company, and if folks are thinking about, hey, I'd love to learn more about Splunk, this is kind of our bread and butter. We deal with cloud-based software solutions that we build and sell, and then we also deal with on-prem solutions that we're also iterating and building as well. So just what does the cloud look like? A couple of different layers within the tech stack that exist today in the cloud. As PMs, you might be responsible for, at a company like Splunk, you might be responsible for any level within this tech stack as a product or service offering. So generally, working in the cloud specifically from the hardware layer up is generally where you're going to be kind of responsible for some level of a product or service. For the teams that I work with, my teams are all back-end teams that run microservices in Go, microservices in PostgreSDB, and then also query language microservices. So these are all microservices that live in a back-end platform that roll up to applications that sit on top of that platform. So I'll just quickly run through kind of what the cloud stack is. You have your application layer. For a platform that we're building, this is generally application that sit on top of our platform. Within the data layer, you might have structured and unstructured data, relational data. You might be dealing with all sorts of different types of databases. At the runtime layer, this is generally where you're potentially dealing with solutions such as MapReduce. We use MapReduce in terms of our, after we index data from customers, how we actually deal with how that data is divided across the buckets that we have within the platform, and then being able to run queries on that data so that when the data is returned back, we can actually reduce the artifacts that have been mapped out across those buckets. I'll go into details about that if you want to learn more about that. But middleware, operating systems, virtualization, hardware, storage, this is going from the user interface and user experience kind of that we interface with when we go to google.com or when we go to facebook.com, and then what's actually running behind the scenes, right? An example of a web app, like I talked about, Facebook, for example, is a web application, but also a mobile application. You might, as a PM, be interested in building an app that might look like, or not look like this, but might be a web application, right? So thinking about what are the services that my web app should actually be responsible for. Maybe it needs to have some layer of caching. Obviously, it's going to have some type of web server that's going to be, transitioning information from the UI to the web server itself and to backend services. AWS is one example of a cloud service provider in which you can have tools like this already available for you to access. So, when you're thinking about building a web application, for example, you as a PM might not necessarily be responsible for thinking about all of these different microservices itself. But if you're working in a tech company or if you're building a startup, and don't have a team, generally you might have to start positioning yourself to understand this type of information if you're interested in building web applications, right? I've talked to you a little bit about the stack itself, and looking at the stack, you have to technically understand what the software architecture will look like if you're thinking about building a web app, mobile app, some type of computational solution, or any of the other examples that are in the cloud today. I won't go into too much detail here. This is just a primer, really, just to provide the context behind some of the examples that I'll talk about later. But again, software architecture design here, we have kind of back-end services that you might have within a data tier. Within an app, a web tier, you might have other types of transactions that are happening between the user input and the back-end. And then the client tier is basically the user experience, the UI. What is that going to potentially look like? This is all from the perspective of software architecture. So at Splunk and many other companies as well, oftentimes when you think of the customer that you're building a solution for, specifically in the cloud, you don't want to release, let's say your team has built a version 1 of a feature or a capability that eventually will be handed over to a customer. Generally, you want to test that before you actually put it in the hands of a customer. So at Splunk and many other companies I've worked in the past, we deal with different types of environments. So for example, generally where we're actually building and iterating is typically called develop or a sandbox environment. So generally, this is basically, from the cloud perspective, some type of non-clustered or full stack instance. Engineers, administrators, DevOps typically have access to this type of environment. What typically happens next, at least in the companies I've worked with so far, many of you guys might be able to relate to this as well. If you're, if you're an engineer or have been working in, software types of environments or whatnot, is a QA environment. So within the QA environment, this is where actually you have a QA team or unit testing team actually testing code that's been developed in a lower level environment. So in the previous slide, we were looking at the sandbox or the development environment. You might have a similarly stacked environment that's solely dedicated to testing. You might have a team that is helping validate the fact that, hey, our development team has built this feature. Now let's test it end to end, identify bugs so that we can solve them before we actually hand them to our customer. UAT, our user acceptance environment, is generally an optional environment. So I won't go to too much detail here, but for companies or for startups that are actually using this type of environment or solely dedicated to kind of using this type of environment for target functionality, user interface improvements, user experience improvements. Performance environments are generally dedicated to specifically running stress tests. Is anyone in the audience familiar with stress tests? Okay, so this is generally where before you actually hand over your V1 to your customer, you want to be able to test load. You want to be able to test all the edge cases related to kind of volume that your application, in this case, whether it be a web or a mobile app, might be able to handle. Because let's say, for example, you're Facebook and you launch your first version of Facebook, and then all of a sudden you get universities across the across the United States, bringing down the application. You want to avoid that. So for a company like that, back when they first started, obviously they didn't have the knowledge to build performance environments, but eventually learned over time, right? But with cloud environments, it's very easy to spin up instances of environments that might duplicate a lower environment. So back then, we didn't have AWS or GCP available to spin up instances in a matter of minutes, right? So no point or blame to folks at Facebook for that. My sister works there, but anyhow, the last environment is the production environment, and this is generally the environment where we've promoted all the code that's passed stress tests, that's passed load tests, that's passed unit tests, QA tests, to this dedicated environment in which customers would actually be able to interface with, right? We don't want, as a PM, to be able to ship product to customers with the intentions of them finding bugs and then not being satisfied, right? If you download an app and it's full of bugs right out of the gate, what's going to be your impression of using that application in the future? It's going to be pretty poor, right? So for PMs, we have to be very, at least at Splunk, and for folks who are actually thinking of getting into PM, we have to be very cognizant of what our customer experience is. And that engagement at the very beginning can make or break kind of the relationship that you'll have with your customer down the road. A little bit more about in the cloud. So you have concepts such as horizontal and vertical scaling. I know this might be a little technical right now, but there's context behind why I'm talking about this. Horizontal and vertical scaling are really dealing with kind of the load that you have with your customers who are coming to your application or your mobile app, being able to provide them an optimal performance environment in which maybe you decide to launch your product in a new region. You might need to scale horizontally to, if you're only operating in the United States and you decide that, hey, we have a market in Brazil, we might need to spin up instances that are in Brazil so that, we don't have customers in Brazil who are running load on instances that run in the United States, right? Or vertically scaling if we decide to introduce more horsepower to our cloud instances as well. In this example, part of the reason why horizontal or vertical scaling are important is because you might have, these dates probably are familiar for most of us, right? In which, if you're a web app like Yahoo, or if you're a web app like Facebook or Amazon, right? These dates typically can have higher volume of traffic to your application. If you're Cyber Monday and you're Amazon, you want to be prepared for that date because you're going to have tons of traffic for people who are buying online. So horizontal and vertical scaling, in this case for Amazon, would make sense to take into consideration. If you're a PM on a tech product, whether it be software, web or mobile, these are other factors that you want to take into consideration as well. At Splunk, we use telemetry to kind of measure the data that lives in the cloud that we get from customers that help us understand kind of user behavior. Just another example of a kind of architecture that AWS offers if you're building a web app. If you decide to want to build an ad serving app. So there's a variety of different ways that you can leverage the cloud for building web or mobile solutions as a PM. So that's a little bit of context about just kind of the technical stack, leveraging the cloud for a product that you're actually responsible for or looking to build. What I'd like to talk about next is, kind of the project management hat that PMs typically have to wear as well. Some of the practices that we use at Splunk, and then, what are some of the kind of ways that you can use some of these practices in a role that you might be in now with intentions of transition to product management. Before I go there though, were there any questions or comments? Feel free to jump in, stop me at any point in time if there's a question or a comment. So I'll put this question to you guys. What are some of the key elements that might be important in today's software environment? Thinking of the product managers that you might be working with in the future, these folks generally have to be responsible for a number of features on their roadmap that eventually might be requirements coming from customers, might be requirements coming from architects on an engineering team. Roadmaps are one tool in which PMs use to kind of drive the requirements that you're getting from customers or from any other kind of internal team members that are asking for features that need to be delivered in a version of a product that exists, right? At Splunk, we use Jira, we use Confluence, these might be tools that sound familiar for folks who work in tech today, or at any company rather, but these are tools that we use to kind of manage that process. Project plans, Gantt charts, a risk plan, which I'll talk about later, or a matrix to kind of prioritize what's important are also ways that you can kind of add those tool sets to your your product management experience. So what are some of the things that make projects fail? I wanted to ask you guys that, but obviously I have the bullets here on the board. So, but yeah, failure to align project with organizational objectives. At Splunk, we have organizational objectives known as OKRs. That might be familiar with folks here in the room. Once a team or a subpart of an organization gets out of sync with OKRs, it tends to diverge away from kind of the objectives of the company. Poor scope. Scope is super important. As PMs, we have to be able to zoom in and zoom out, on any variance of kind of perspective that we need to understand, whether it's from the customer, whether it's from engineering, whether it's from architecture. If a project is not scoped properly, meaning that it might be too broad for being delivered in a specific period of time. If you have a deliverable that's due at the end of the quarter and the scope is too poor, or it's not too poor, but it's too large, your engineering team might not have enough requirements or details to work within that time period to break it down and deliver it by that time frame. The scope can be too fine too, meaning that you rabbit hole into a specific area without thinking about other aspects of a particular feature that you're expected to deliver on from a customer's perspective. Unrealistic expectations. This is a funny one because when you're working cross-functionally with other team members, expectations can get out of sync. So having regular meetings as a PM is important. Setting up that expectation of a regular cadence with the team members with your roadmap, because your roadmap could have a current state today and then next month could be completely different, right? Setting those expectations with the team members that you're working with is crucial. Not having executive sponsorship, lack of project management, inability to move beyond individual personality conflicts. I think that's generally across the board for working in a professional environment. But, as a PM, you have to take ownership of, the fact that these things can happen. Politics obviously can happen, but how do you navigate? How do you navigate these types of potential failures so that your projects are successful? What can help projects succeed? Obviously, we don't want to focus on the failures, but we have to be cognizant that they can happen. Project sponsorship, defining a project charter, strong project management, having the right team, to work with, good decision making, good communication, team members looking forward to common goals. These are just a few. You can come up with your own based off of kind of the teams that you're working with. The communication, I think, is one of the best, if not most important. It's very easy to kind of operate in a silo as a PM because, you might have engineering teams off, building, and you might think everything's great, but the reality could be, mean that maybe your engineering team is building something that they shouldn't be building, right? So how do you manage the communication, not only with your team, engineering managers, architects, customers? That's probably one of the biggest keys, whether it's setting up recurring meetings on some regularly based cadence to ensure that the line of communication doesn't get out of sync with your team of folks that you're working with, yes. Strong project management versus maybe weak project management could look like not having a plan versus having a plan, versus having a plan that's, detailed and structured and someone can actually take a plan and execute on it. And then another layer of, detail beyond that, right? So it's a lot of it is perspective, but it should be enough to a point where a team that's expected to work with a project manager or a product manager in this case to deliver some goal should have clarity around what are the details of this project, what are the timelines, are there dependencies that might exist with other teams that we might need to work with that need to be incorporated into the project so that when a certain milestone is reached, a team can continue and proceed towards the goal without having to be stopped or blocked because of other issues. I'll talk a little bit more about that coming up. So we looked at this slide already. Why does this matter to you? Most of us get to where we are by some technical specific set of skills. Having a good blend of not only what your customers are expecting from the business standpoint, working with your engineering teams if you're building a software product, obviously, being able to navigate organizational politics if you're not a PM on a startup, but this is something we have to deal with. And then some level of technical expertise. I mean, obviously, if you can find the right technical folks to help you, that may or may not necessarily be as important, but from a software perspective, that's kind of the reality today. Learning from your successful projects is also key, right? If you've already completed a project, delivered, customers are happy, you want to take the good from that and reiterate on that and improve on that, right? So, like I mentioned, we use Confluence, Jira, Google Docs as tools to, PMs can use to kind of drive their products. AHA is another tool has kind of a road. I don't know if folks are familiar with AHA, but we use that. It's a PM related tool. It's pretty cool, but it allows you to build roadmaps release by release. It's pretty comprehensive. Planning is important. Risk management planning. Avoid micromanaging. Folks don't like too many meetings more than are necessary. And open communication, again, is important. A couple of other bullets on kind of managing a project. I won't read these in detail. Mechanisms, input, constraints. I think for someone who's interested in kind of strengthening their project management skills, these are important, not tools, but important kind of concepts to consider. The Golden Nine of project management is also another framework that exists for project managers or for product managers who want to build up on their project management skills. Now thinking about the methodologies that you can use from a software perspective to build product, some recommended practices. We'll look at kind of what a comprehensive engineering plan looks like. And so, yeah, like I mentioned, you might be responsible for requirements that come in from a customer. who says, hey, we like this product, we want to see version 2, it should have X, Y, Z features. As a PM, you're going to be on the intake side of those requirements. You might have other requirements that come in from other internal team members who say, hey, I think we should actually build this or add this to this existing, whether it's a feature or a product that we have today. So you're in the driver's seat of managing the requirements and then building use cases that your engineering team can understand, right? If your engineering team can't understand kind of the use case of what they're building from a software engineering standpoint, like they're not going to understand how to build it optimally for you. User stories are also critical. You want to frame your stories in Jira, for example, in a way that an engineer can say, hey, okay, if I can read this story and get clarity on how it's going to impact the customer and how it impacts the rest of the platform or the software that we already have today, because they're already going to know that, then it's going to be a much easier way for them to say, hey, okay, this is why we need to build in this direction versus any other direction. So sprint planning is generally we do that every 2 weeks. And some of the contingencies for sprint planning entail what's on our roadmap, what's already past design from a design review perspective, and what's in our backlog, right? I'm assuming these concepts are relatively familiar with folks. If not, I can, go into detail more. But that's the requirements swim lane. The project planning swim lane is equally important. This is where a PM will be deciding with the engineering managers and architects about, hey, we have this year outlook for our roadmap for a product that you might be responsible for. If we're going to be, let's say, for example, we're on a quarterly release plan, what release are we going to start mapping requirements or milestones into, right? You could have, we just finished a release called, well, actually, we're finishing a release called Icebox that's supposed to finish on February 3rd. So at Splunk, what we do is, for the products that I'm working on, we all know A through Z, right, is the alphabet, right? So before Icebox, what's the letter before I? J? H. What did we have? That's before I, right? H, I, J. Okay. So H was, what was it called? I'm trying to remember. Anyhow, Icebox is the current release that we're in. We're going to Jammy Dodgers. The release after that is Keebler. We've decided, so if you're familiar with Google for Android has kind of like, they had Marshmallow, they had all sorts of like candy and dessert types of names for their releases. At Splunk, we're doing the same thing, but we have those for like cookies, at least within our platform or whatnot. I can't remember what the H was. I don't know why, but anyhow, we give our release names these types of mnemonics so that we can, from the software standpoint, have a common kind of way that we understand releases. An iteration plan is kind of how often are we going to be iterating. We do biweekly sprints. A daily plan may not necessarily be critical. If you're an engineering manager, you might be doing daily stand-ups with your team. Planning poker is important. I won't go into too much detail there, but that's basically figuring out how to break down a feature into stories and giving them some type of quantitative timeline in terms of how long is this story going to take to complete, and then getting consensus or buy-in from the rest of your engineering team to say, hey, okay, we agree that it takes 3 days, 5 days, 7 days to deliver this particular story. I mentioned the architecture. That's usually design review, going from the idea to design, in relation to the existing architecture. Managing configuration. This is thinking about, version control and, the flexible work environment. So managing quality is also equally important. We do, at Splunk, we just recently spent an entire release focusing on, understanding the quality of our code, because to a degree, you might, as a PM, might be pressured to deliver. And you don't want quality of your code to suffer as a result of that. And as a PM, you're not actually writing code per se in most roles. You might be in some, but um, you don't want the quality of your code to suffer where then you now have this extraneous backlog of bugs that you then have to conquer later on down the road, right? Managing risk, I'll show a slide specifically about risk, but this is more or less thinking about, hey, how do we prioritize the requirements? You might have a set of features coming from customers, coming from internal partners, coming from internal teams. You want to be able to rank that list to figure out, hey, what's most value added, versus what's less value added. What can we defer to another time? What are requirements that are actually going to impact our bottom line? So managing risks that way is also equally important that PMs generally are going to be successful at if they're taking those into consideration. Testing is kind of out there to a degree. It's part of the process of Agile and Scrum that we incorporate as well. So these next three, supporting the support team, the implementation and deployment, I think I've talked about these to a certain degree. For the support team, we have retrospectives after every sprint in which the team can provide feedback about a recent sprint. The team lead is part of that team discussion for those retrospectives. Tools for distributed collaboration, I think we're using Confluence, we're using Jira. If the engineering team decides to change how we deal with our CI/CD pipeline, these are just part of the conversations that are iterative every sprint. In terms of the implementation, we're looking at story points that are implemented, new story points that are requested. This generally is part of the sprint planning process and the backlog grooming that we have. Deployments, this is when we actually ship. So for us at Splunk, for the platform that I'm responsible for delivering specific services on, we're kind of a CI/CD, so we don't necessarily wait for a date in the future. Once a feature is ready, we ship it, and it's there. It's in the cloud. It doesn't need to wait for any type of sign off to a degree. You might be working in an alternative environment where you might have to get sign off or wait for a release to ship a set of features at some point in time. But that deployment generally will deal with the end of lifecycle testing, transition planning, depending on where you are in terms of a pilot or a beta. We're in beta right now. I can give you guys the URL to our product, etc. I think that covers most of the process and practices that I wanted to talk about. This is an example of maybe a team that you might be responsible for in the future, or right now, currently. Obviously, you're thinking about the staff, who are the leaders, architects, devs on your team. It could look like any variation like this, and you might have some window in which you're working with a budget to act on, right? For that MVP that you're building, you're going to have a date in which you're going to start building, and a date in which you're expected to deliver. Everything else in between could be contingent on how frequently your sprint cadence are, how frequently you're going to be, or what's going to be required in terms of the initial phases. How long will it take to demo, etc. Right? This is just hypothetically what you potentially would encounter if you're now a PM responsible for delivering a new feature coming into a new company, right? This is a window of time in which you will need to be able to own and act on, and you have that responsibility to then decide, hey, what needs to shift, what can stay, etc. After that first release is done, you might then be asked about, hey, what is release 2 going to look like? Does it need to be integrated with other third-party apps or first-party apps? Is there any customization? What other features or requirements will now need to be brought into this next release, right? Customers obviously is front and center of every PM. Without customers, your business doesn't operate. If you're not selling something to people, or they're not buying anything from you, you're out of business. So thinking about your customers, you can think of them from a telemetry perspective, right? At Splunk, we have beta customers for our platform right now that we basically have to make happy, right? Because they're paying us for the products and services that we're building. If we lose that relationship, that's not good for us. And a PM who is in front of a customer wants to ensure that that relationship is top notch. This is just a diagram kind of outlining kind of potential customer growth contingent on a product or service doing well. Revenue and gross profit are also kind of factors that you might be responsible for from a P&L perspective. You want to take into consideration that you might have requirements that can drive revenue and gross profit for your company or for a product. So having an outlook on, what that potentially could look like is equally important. It might not be important in all PM roles, but as you start to get in more customer-facing roles specifically is where you'll actually, customer-facing roles from a PM perspective is where you'll actually have to start to consider revenue and gross profits, net income. If you're at a startup, you might be responsible for payroll as well. PMs generally are not responsible for payroll. I'm not responsible for any payroll at Splunk, but if I'm building a startup and I'm a solo founder, I'm thinking about who I'm going to hire on the engineering team. This is something you might have to take in consideration, right, for some runway that you might have. Sales, how am I going to make money? What's going to be the lever that we're going to, extend to our customers, whether it's a subscription, what have you, thinking about, hey, how many customers do we need to have to meet some revenue target in a specific year? Income statement. I talked about, risk was on a previous slide as well before. This is very important. Well, in my mind, this is very important to take into consideration because having a matrix like this where you have on one axis the impact and cost and another axis the probability of it actually happening gives you kind of a perspective of what's going to be the most risky set of encounters that we might deal with, whether it's not having enough resources in your team to deliver on a feature, your product failing to meet the customers. I think if we look at the top right, R2 seems to be the heaviest risk, meaning that the project costs exceed the project budget. R7, R3 is delays in development time and future. R7 meaning missing periodic sales targets, which are directly related or reliant on revenue targets. You can come up with kind of this matrix to figure out, hey, for our product and service, what are some of the risks that we want to avoid? Anyhow, those are risks. Opportunities is also another matrix that can help you kind of look at ways that, from a PM perspective, you can, identify gaps that might exist to ensure that your product and service that you're responsible for are successful, right? In this case, we have a similar matrix, right? The lowest impact, lowest cost, highest probability in this matrix was 06, surpassing minimum sales targets that incentivize sales and marketing via commissions. Depending on kind of your product and where you stand in terms of the product and service that you're offering, some of these may not be relevant, but it doesn't hurt to have this outlook of the opportunities that you could then start to, focus on, right? That will help your product and service offering. So these are things that just generally you can come up with on your own or might exist in a company that you work with today. So the call to action, again, in the first couple of slides, there was a video that I shared that let me slow down. There was a video that documented a software engineering plan that I think is crucial for PMs who are looking to build a particular product, specifically in software. This software engineering plan generally is a way that allows you to define your MVP, define a future release schedule, and be able to deliver this plan to a team who can get clarity on what your vision is for a product or service. I'll go into detail a little bit about what that actually looks like as it relates to a product that I was responsible for. This matrix is a little bit more, multifaceted compared to the risk, which is kind of, pretty vanilla to understand. But I think the key here is to understand what's the current state of the world for your product and service offering. What's the gaps? You might have to take a look back at your risks and say, hey, if we look at all the red risks and we look at all the potential opportunities that we have, how can we start to mitigate against the risk with opportunities, right? You can look at them simultaneously as well. So yeah. I thought I saw another hand, but okay. So prioritization, I think, is equally important as well in relation to the software engineering plan and your roadmap. I talked about, hey, how do we decide what goes in first versus what we can defer to later? Having a kind of quadrant like this is valuable to have, because you don't want valuable requirements and valuable features being put at the back of your backlog and never getting done, because what happens in that case is you end up building features that are lukewarm to a customer versus features that are still in your backlog that you haven't brought up to the top of your backlog and delivered, that might be features that potentially could bring in new customers that could drive your bottom line, et cetera. So prioritizing it, at Splunk, we use a P1 through P4 classification, P1 being the highest prioritization, P4 being lowest. And then we also use sizing to kind of decide, hey, what's our P1s? How long is it going to take us based off t-shirt sizes that we've defined for specific requirements that are on our roadmap. These are just a few different software methodologies that you might adopt in your engineering kind of team or whatnot. We use Agile, we use Scrum. Okay, so a couple of examples. This is a software platform that I was working on before I joined Splunk, called CloudSurf. The intent here was to deliver a web and mobile solution to the general aviation industry, similar to Airbnb, but for the GA industry, focusing on hangars and tie downs. The question is, okay, well, where did that idea come from, right? So I'm a licensed pilot. I work with flight schools as well in my free time. That first image on the left is how Reading Airport deals with pilots who are looking to land and park their airplanes for some period of time. We're looking at a pen and clipboard interface to deal with parking, right? Most of us are in technology and know that we have tools that potentially could replace that, right? So my thought was, hey, look, this is, the dinosaur ages. Why are we still dealing with this type of means to deal with parking? So spend some time as a project really just thinking about the problem. Who are the customers? In this case, airmen, flight schools, aviation vendors, flight clubs, figuring out some of the inherent issues that they might have had. This is a video of the requirements document that I put together before I started anything, but this was basis behind going from identifying a problem to then coming up with the requirements that a team potentially could then run with, that was comprehensive enough that identified, hey, why are we building this? What are we building? What would this MVP look like? How long will it take? What are the costs? Just more value proposition here, thinking of the customer. The intent in the phase one is to digitize hangar and tie-down reservation system for fixed base operators around the world, to replace this kind of interface that airports were dealing with, general aviation airports. So eventually started with this enterprise portal. Looks somewhat similar to kind of a LinkedIn interface. Worked with YC Startup School. I got feedback on this. A little bit about the value proposition again. Some of the team members that I work with across the board. A very high level roadmap. What the intentions were at the time. A little bit of market analysis, competitive analysis. What did the business model look like? How is this potential startup company going to make money? What are the possible solutions? So thinking of the designs, actually building a version 1, as you guys can see here in the videos that are going to be populating here shortly. So spend a lot of time with the requirements plan initially right out of the gate with intentions of figuring out, hey, what's a V1 that potentially could attract customers, attract possible investors who might be interested in this. Um, Propose an alternative solution on mobile as well. This is another project that I started before the aviation project as a graduate student. I had a friend of mine who I grew up with in high school is a professional barber, and we had this idea of working in the hair industry. As you can see how much hair I have, but as a professional barber, he identified how many issues existed with the fact that technology hadn't been leveraged in this particular industry as much. So we thought about some ideas. Another colleague of mine from grad school, we put our heads together and started asking questions about what this potentially could look like. Again, started with the requirements document. Started asking questions. It started as a project in grad school, but we started to come up with questions that we could address as a solution. Market analysis. What was our value proposition and proposal as a solution? Put together a version 1 on mobile just to kind of highlight, hey, what potentially could this look like? Who are our customers that would interface with this? There's a multifaceted, marketplace that we were proposing. So I think the point here is that, looking back on what we talked about in the slides about just the technology stack, the requirements, the agile development, working with an engineering team, were all basis to get to these 2 points of having some software solution in place, because it started from an idea, but eventually, over time, with the requirements document, you're put in a position to ask questions that you need to have answers for, and then you can then translate those into, proposals that engineering teams could then go with. Yeah, so current opportunities that we saw, current risks that we saw. We were thinking about hiring as well, working with YC at the time. We were hoping to raise some money to hopefully bring engineers on board to help us build. So we obviously had to think about that as well. Having a roadmap. This was a very, very early roadmap that I cringe at now looking back, but this was 5 years ago at the time, and I probably would have done a different type of roadmap style at the time, but figuring out what our criteria for success were, and yeah, that's about it.